Hello everyone, my name is Stolf and I will be guiding you through today's lesson. In this lesson, we will be exploring activities for the Grove Red LED module. The LED, also known as a light-emitting diode, is a component that emits light. This is primarily used for providing visual light feedback in various electronic devices such as remotes, radios, speakers, and the likes. The Grove Red LED module is a digital component that uses only the output and not the input. For this lesson, we will be doing three variations using the LED. First, LED blink, second, LED fade, and the third, LED serial control. Our hardware setup will be composing of the breakout board and the LED module. The Grove LED module connects to the board through the digital pin. Note that if you haven't taken the modules out of the breakout board, you don't have to connect them using the Grove cables because the modules are already connected through the Grove base shield. In this video, I will be demonstrating to you how you would connect the Grove cables if you were to take them out of the breakout board. Plug in the LED module to the digital pin marked D6. You can also see this label on the breakout board. This connection will be the same all throughout the activity. Attach the shield to your Arduino Uno and connect it to your computer.
We start by defining the LED and the pin. LED here is user-defined, so you can put whatever you want. It could be red LED or LED pin. Then in void setup, we identify if the LED behaves as an output or an input by using pin mode. And in the void loop, we put our main code, which runs repeatedly. Digital write identifies whether the LED is set to high or low value or high or low state. High state means the LED is supplied 5 volts or on, then low means that the LED is supplied 0 volts or off. The delay pauses the program for an amount of time in milliseconds. So in this case, it's paused for 500 milliseconds before processing the next command. We save the project and upload it. The second activity we will be doing today with our LED is LED fade. So what this activity does is it introduces the use of analogWrite function. This function uses pulse width modulation, thus turning the digital pin on and off very quickly to create a fading effect. Here we introduce new variables, which is light and fade, where light is the amount of brightness of the LED and fade holds the value to fade the LED by. This becomes understandable once we see the main code. In the setup, we again declare the LED pin as output, and on our main code, we use analogWrite to set the brightness of the LED pin, as opposed to the digital write, which only had two states, the high and the low. So the equation here we will be using changes the brightness as the main code loops. While the if statement allows to reverse the direction of fading as it nears the end of its fade. Lastly, we have a 50 millisecond delay. So once you're done with the code, save it and upload it to your Arduino. Once you upload the code, you will see the results wherein the LED will fade in and out. The final variation for our LED is controlling it via the serial monitor. What this does is when you input a certain value on the input field of the serial monitor, it will either turn the LED on or off. So what we do here is we put serial.begin. Serial.begin sets the data rate in bits per second for serial data transmission. 9600 here is our speed. Then we use serial.println to print the instruction on the serial monitor. We put the instruction in the setup because if we put the instruction on the loop, it will continue to print as long as the code is running. For the main code, we use the conditional statement if. So here, when the statement is proved true, it will perform the following tasks. So if the serial is available, it will retrieve the value you place on the input field. ParseInt here returns the first valid integer number from the serial buffer or the input field and store it on the variable num. We use int because num is going to be a number value. Then if the number retrieved from the input field is equal to 1, it will set the LED to high or LED on. Then it will print LED is now on the serial monitor. Then when the number is 2, it will set the LED to off. Notice that we use digital right here because we only need to use two states, high and low. Once the LED is turned off, it will also print LED is now off. Now, you may also input numbers such as 3, 4, 5. So if the detected number is higher than 2, we put that the input value is incorrect. So sorry, you have entered an invalid number or an invalid command. And then it will again return or print the instruction. We save this as a new file, name it however you want, and upload the code to our Arduino. When you open the serial monitor, you will see the following. So the instruction here is printed only once, and when you input 1, it said LED is now on, 2 LED is now off, and when you input an invalid number, it will prompt the sorry.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.